Good morning, folks, and welcome to this PCCE Dial Plan Tech Talk webinar from Sunset Learning. My name's Bruce Wilkinson, and I'll be running through this session and a couple of other sessions that we have planned for today as well. All of these sessions, by the way, are coming to you from the newly crafted CCEI implementation class. And what we've done, which is not yet launched, so you're sort of getting a little bit of a heads up in terms of what the class might contain. In this particular session, we want to talk about essentially personalizing a packaged contact center enterprise deployment. And by personalizing, I mean once everything has been built, there's still a need to confirm dial numbers and dial plans in each of the products that make up the CCE environment. If you're familiar with these products, just very quickly running through, there's dial plans in the SIP proxy, in the egress gateway. There is dial plan in the CVP server, in ICM, and of course in call manager. And all of those devices need to be considered when we are building out this particular sort of dial plan for our customer. So our starting point in this discussion, and in fact in the lab environment that we're dealing with, is that we have a functioning PCCE already built, and we're now just going to add some toll-free numbers. Agents, we're assuming, have extensions. We're saying 1000 through 1999. Calls are coming inbound from a carrier across two ingress cube gateway devices. We'll want to show the inbound dial plan for these toll-free numbers, as well as the dial plan in our virtualized voice browser and ICM and CVP as well. And we'll also, towards the end, talk about this concept, if you will, known as significant digits. I'm not sure how the timing is going to go for this particular session. It may go a little beyond the 1 hour that's allocated. If that's the case, what I'll do is take a little bit of time from the follow-on Tech Talk session, which is preparing software, which is something of a shorter session. So anyway, that's all sort of by way of introduction. A formal description, if you like, of a dial plan is that it is an allowed sequence of digits that are dialed, and the rules of how those digits are going to be manipulated and forwarded for the purposes of call routing. There are a couple of principles that we define quite heavily, if you like, in all of these dial plan considerations, and that's the concept of patterns and paths. And essentially, a dial plan is just that. It's a collection of particular patterns pointing to particular communication paths. And of course, each of those paths are going to be implemented via one protocol or another. If we look at the components in our system, yes, I might have skipped a slide here, just excuse me. If you look at the components in our system, this table, if you like, defines the role and the mechanisms per component of those devices, and also gives us an insight into a number of the wildcards that these products support. And you'll see, just with a sort of a brief perusal of this table, that not only do we have several different components in our solution, but each of them, sadly, supports a different set of wildcards. Wildcards, as we probably know, are important components of any dial plan, which allows us to conveniently select a range of patterns to point to a particular path. The dial plan mechanisms for each of these components are listed here in the gateways. For instance, we have dial peers, In CUSP or SIP proxy, we have triggers, router groups, server groups, etc. In CCE or ICM, we have our dialed number, our VRU labels, etc. In CVP, route settings, route patterns and destinations. Both of those, by the way, administered by the single pane of glass or SPOG. In our voice browser, also administered by the SPOG, we have device configuration requirements for what are referred to as applications and triggers. And what we'll do is expand on each of these as we move through this system. And also in Call Manager, of course, route patterns, trunks, translation patterns, etc. Now, I'm assuming, I guess, to some extent that those terms are not sort of revelations to you. They are, somewhat familiar. In our implementation class, of course, we've got more time, I guess, to go through these in more detail. But here in this 1 hour that's allocated, we'll move through them probably a little more quickly. So looking at the dial plan then, the configuration for that dial plan in each of those devices, starting with the ingress gateway and or cube. At the basic level, if you like, there's not a whole lot of difference between a voice gateway and a cube. Cisco Unified Border Element, by the way, is the expansion of that cube acronym. And it's really just an ingress voice gateway with some additional coding. The voice gateway, or the basic voice gateway, if you like, implies one side of the telephony coming from the carrier as either a TDM trunk or ISDN or something of that nature, and on the output side, VoIP. Cube implies VoIP on both ends of the telephony call, and it's usually going to be a SIP to SIP environment. So clearly what we need in the ingress gateway is some coding in the VOS that not only is able to recognize the SIP input to that gateway, but also do maybe address translations, some SIP to SIP conversion, because not all SIP versions are exactly the same. So Cube provides those additional facilities. Note that voice gateways don't automatically trust the originating endpoints by default, meaning that there is some certificate work to be done with those devices. And CVP, when we're talking about our voice gateway, sort of delivering a SIP invite to CVP, CVP automatically passes on any SIP invite that the gateway might present to any downstream devices without any dial plan configurations. Not so on responses or incoming services. That's where the dial plan in CVP really comes into its own. In that gateway, of course, we use the term dial peers, and dial peers are a way to define that part of the dial plan on the voice gateway. And again, the two things that make these dial peers work for us are patterns and paths. If we look sort of at something somewhat of a high level, I suppose, of a gateway environment, just to put these patterns and paths and call legs, another term in some sort of context, here we see an ingress gateway. It looks like this is a cube, and the reason I can sort of make that assumption is that we've got VoIP in the exchange environment and VoIP coming out into our network. So the call leg is defined as the logical connection between either two routers or the routers and a telephony server. So here we've got sort of 1, 2, 3 call legs. We're assuming that call leg 1 is answering the inbound call from any trusted service provider source. Call leg 2 is forwarding call setup information to CVP1. And call leg 3 is a redundant call leg to the other side CVP server if the primary is unavailable. The dial peers, so called in this gateway, are defining then the characteristics of a particular call leg. They'll define the pattern, the path, and the protocol that needs to be used. And this again is sort of provided here in just a little more detail, if you will. The allow connections command, by the way, here is further confirmation that this is a cube, more so than just VoIP as the gazinter and the gazouter, as we sometimes say, for this particular gateway. But call leg 1 then is defining an incoming call number. Notice it's got a range of numbers. The session protocol is SIP v2, and the second session target 152.168.1.3, which is defining the output port on that gateway. Call legs 2 and call legs 3 then are defining the destination target for each of those call legs, as well as the session protocol, again, SIP v2. Notice also these little boxes here are simply defining these CVP servers, server 1 and 2, and referencing those in the SPOG inventory tab in the CCE admin page. If you've been following the session so far, you will have noticed that we've gone through the SPOG in some detail with reference to those inventories at least. So this is what our dial peer is doing for us in this particular gateway. I'm not sure we need to go into too much more detail about that. The dial peer 800 is defining the call leg, which is matching the incoming calls with this DNS. We mentioned the range 40 to 59 for this particular scenario. Notice wildcards, including the expression that 45 in brackets here is defining the range. Now, you may or may not be familiar with gateway iOS commands. If you're not, and it's not unusual for CCE administrators to be not that familiar with gateways. And the purpose here is not to sort of teach you about, gateway commands, etc., but just to give you a little bit of an insight into sort of what's happening, I suppose, out in the gateway routing and switching world there. The default preference, by the way, for a call leg is 0. And if you take a look here at this call leg 2, it's talking about preference 1. So both call legs 2 and 3 attempt to set up a SIP call, but a preference is being given here to call leg 2 by virtue of the preferences that are being dealt with. So assuming the CVP server was running correctly, it would accept the SIP invite and, as we say, automatically forward the inbound request to ICM or CCE by way of the gateway. Not shown here, but we'll talk about it a little later. Also some dial peers for error tones and ringtones, and there are some sort of reasonably standard features for those facilities. So that's, basically our ingress gateway. The dial peers 9191 and 9292, there's nothing magic about those strings, by the way, but I guess it would be fair to call them standards. You could divert from that. You could create 1, 2, 3, 4 as a label for a caller to hear ringing, and 1, 2, 3, 4 for a caller to hear, 5, 6, 7, 8 or something different for a caller to hear an error message. As long as everywhere that you needed to reference that dialed string or that pattern, you were consistent. So why wouldn't you use, what everyone else uses and what, Cisco TAC would be expecting should you want any support. But it's important, I think, to put these things in context, that there's nothing programmatically significant about a particular string in that regard. What matters is consistency. If we move on then to the CUSP or the SIP proxy dial plan, our SIP proxy is sitting here as part of our IP network. SIP proxy, by the way, is not compulsory in a CC or a PCCE environment, but it's almost certainly going to be there just because of the complexity of the network. I like to regard SIP as really the telephone book, if you will, for IP addressing. SIP is a peer-to-peer protocol, so for devices to communicate with one another, they need to know the addresses of all of their peers. Now, in a large network, that can be, a fairly complex network addressing table, whereas if you've got SIP proxy, that task is taken over on behalf of those devices, and therefore that SIP family of products then on the network need only know where SIP proxy is, and SIP proxy knows where everyone else is. So it becomes a much simplified network addressing table. Now, once you do that, of course, you're able to add some other powerful tools into that SIP proxy device, such like time of day routing, call admission control, and a whole bunch of other stuff. Traditionally, CUSP is going to be deployed on a network module of an integrated services or ISR router. Later versions, you might find this in 12.5. CUSP is going to be run on a virtual machine of some type or another. To administer CUSP, it's a browser-based administration, and it will allow you to define, if you will, a number of different processes and features for our device. So to summarize, SIP is supporting a centralized dial plan and simplifies what otherwise would be some fairly complex addressing tables in each of these devices. The devices now only need to know where SIP is, and SIP knows where everyone is. As we mentioned, to administer that, you'll use a browser, and you'll define things like triggers, route tables, patterns, endpoints, etc. It's not a trivial configuration because it's not because it's powerful. Okay, and whenever you get that power coming into the event, it requires you to be careful with the configurations. And this is, I guess, a high-level view of the call flow, I guess. You would configure these things in reverse of the flow, but a dialed number comes in called a trigger, and that will map to a route policy table. What do I want to do with numbers of this nature? Okay, depending on the trigger, I could have different route policies, etc. Those route policies go to a route table, and from that route table, I could direct calls directly to an endpoint or direct them through some server group or some route group. So you can see I've got the opportunity to be quite flexible in the call control that I use in my SIP proxy. Now, this is not, again, something that I believe a CCE administrator is necessarily going to get involved with in any great detail. Rather, your routing and switching guys are more likely to be the folks that are involved in that level of detail. The dial peers in our gateway, though, that use this SIP proxy is going to sort of look like this, in that we now have a dial peer coming in, and you might have seen previously the dial peers pointing to the CVP A or B. Now we have a dial pair back in our ingress gateway, which is pointing to a session target SIP server. And SIP server is a service in the gateway that is pointing to the IP address of our SIP proxy server. So there's no magic in any of this. If it's not going to work, if the dial pairs and the configurations are not sort of correctly created, and if this dial pair is used on the ingress gateway /cube, then this SIP invite is going to be sent to the CUSP, which is going to trigger that lookup of the dial number, whatever it's going to be, 800 555 39 something something in our example here. That'll point to a trigger, a defined trigger in CUSP. And hopefully, you know, if everything's configured correctly, CUSP should point that to the same CVP population as we saw in our no proxy event. Many ways to skin a cat, in other words. Our ICM dial plan. So we've looked now at our ingress gateway, our SIP proxy. Now on ICM, there's clearly quite a bit of work to be done in defining, if you will, or configuring our ICM dial plan. Notice again that anything that's coming into CVP, you know, from our SIP proxy or from our ingress gateway is automatically going to be delivered via the PG into our ICM central controller. There's no need, if you will, to do any configuration in CVP to make that happen. It's automatically forward via the VRU PG to ICM. The response from ICM comes back in the form of a route response to that originating routing client or CVP server. So what's then in our ICM route plan? ICM, as we've often referred to, at least in our classes, the great decider. Every time a route request, which contains the dial number, is coming into ICM, ICM needs to define the appropriate destination for that call. And the sorts of things that are going to be necessary to configure in ICM to make that work are firstly, of course, the incoming DNS. If I deliver a dial number into ICM, say 1234, and that dial number as a route request, and that dial number is not configured in ICM, then that route request will be completely rejected. ICM will not be able to process it. So the very first thing we need to do is to add those dial numbers. And we need to add the dial number from each of the potential routing clients that potentially could deliver that call. I'll leave the dialer out, but just, you know, considering, say, CVP, and there might be several of them, and say call manager, all could be potentially delivering a dialed number XXXX into ICM. XXXX in ICM then needs to be configured for each of those routing clients. And if it's not, then it might, if the number comes in from here and that's configured correctly, then that might work. But if the second number comes in from, say, the standby CVP, and that routing client is not part of this configuration, then again, that will be rejected. We'll talk later on in this session about call manager inputs into CVP and the appropriate configuration that's required in that device. Remember that ICM does not touch the call. ICM is only ever dealing with signaling, but it helps redirect the call or makes the decision as to where the proper destination for this call belongs. So it will direct CVP to deliver the call to either the virtual voice browser or a VXML gateway for IVR treatment. And it'll do that using something referred to as the send to VRU node, something we'll look at a little later in this session. It might direct a call to an agent directly or to an agent using a skill group or precision queue, or it might send the call to a help desk number or something of that nature using a label node. They're sort of really incidental to the dial plan to some extent, but just realize that this is what ICM is doing. There's something in the configuration called agent targeting rule. We'll talk about agent targeting rule also as we move through this. It's used as a final agent selection criteria. And of course, the peripherals that we're delivering our route responses to also need to be properly configured so both ends of the communication path understand what's going on. If we look at the SPOG and we come to the SPOG in our call settings, route settings, here is where we'll deploy our dial numbers. And in this example, we've got the same dialed number string, but we've got two different routing clients. We've got an external voice routing client and an internal voice. This dial or this configuration is assuming an agent has dialed 800-555-3952. It's an internal voice. This assumes that a caller has dialed this number via the ingress gateway and CVP to then come into ICM. Our call type is identical for both of these. The call type, as you might know, is the necessary mapping between the dial number and a script. Call types are also used for reporting, so it's important when you're configuring or designing your call types to have attention to call type names and naming conventions. Very, very important to make your reporting sort of more sensible, if you will. In package, what we're seeing here is this one external voice automatically assigned to two routing clients, C5001, C5002. This is CVP1 and CVP2. In packaged, that happens automatically. Why? Because in packaged, you already know you've only got two CVPs, two CVP servers, and you know what their routing client ID is. If this, and so you only have to enter that dial number once. If we were doing this for, say, unified as opposed to packaged, then we would be required to enter that dial number and manually assign each and every potential routing client to that dialed number. The reason is that architecture is not predetermined, so the system can't make any assumptions. So this is sort of one of the benefits or advantages, I suppose, of the packaged philosophy. Those numbers, by the way, C5000 and 5002, come from the routing client ID that you would see in the inventory card from the SPOG. In a similar way, the dial number records here for our call manager is assigned to one routing client, U5000. Now, why only one? Don't we have a publisher and don't we have several subscribers? The answer is yes, we do. But this is referred to as one cluster and therefore one routing client. Again, the routing client ID for that call manager cluster, we can determine from the inventory part of the SPOG as being 5000. That send to VRU node, the send to VRU node is likely to be the first node that a routing script will encounter. So we've dialed our number, we've got our dialed number call type properly configured, so we will fire up a routing script. The very first node we are likely to encounter or should encounter one of the first anyway, is the send to VRU node. There's nothing to configure in the send to VRU node itself. So everything that happens here is going to essentially be under the hood. And what the send to VRU node is going to do is to examine the configuration that's been created in the SPOG and find a configured label, just a string of digits, and return that to the routing client that sent in this route request. You'll do that configuration in the SPOG under call settings miscellaneous, where you'll see, again, the ability to create labels for CVP, for call manager, and if we were doing outbound option for the dialer. The default values are shown here, that we've got our CVP label 97s, our outbound label something different, and our call manager label something different as well. Now, they are there by default, but you can get to change those if you wish. Point is, whatever you define here needs to be defined in a coordinated way in the corresponding peripheral, i.e. in the dialer, in CVP, or in call manager. And here we've shown some differences, if you will, in terms of what we might have created. And this in fact is what we've created in our lab workshops in this class. This 10 digits here is there for a reason, and we'll show you the significance of that later on. Realize also that the label that goes back is this 10-digit label plus a correlation ID, which is just an integer assigned or attached to the label that starts at 1 and goes through, I think, 3000 or something like that, and then resets, and it provides an individual description or reference for that particular call. Best practice would suggest that you always have the send to VRU node in your script. If you didn't, then the first run external script node that you encounter in your routing script will do the same thing. So, some folks will say, well, if that does the same thing, why do I bother with an extra node? Well, the answer is troubleshooting. Because if, say, this external script node fails, let's say you didn't have a send to VRU node, and the external script node failed, how do you know why it failed? Did it fail because you couldn't run the application? Did it fail because you couldn't find the WAV file? Or did it fail because it didn't even go through this initial send to VRU dialog? Point is, you don't know till you examine the logs. However, if the send to VRU node failed, then you know for sure that there's something wrong with this configuration. No need to go looking at any scripting because you haven't even got there yet. And if that send to VRU node passed, in other words, passed the check mark, and your external script still failed, then you don't have to go looking at the underlying VRU labels and that configuration. That worked. You can hone in directly on your application or your WAV files or whatever the case may be. The agent targeting rule, as we've said, is a way of defining the particular agent extension against a routing client. Again, in 12.5, I think it came in, the agent targeting rules have been pre-configured, and therefore there's not a lot of reason to do anything for it. Now, by pre-configured, what I mean is you've got all of the potential properly named host devices, the call manager, CVP1A, CVP1B, and any multi-channel stuff. Now, how do we know that those host names are correct? Because this is packaged, and because when we run through our installation wizard, it assigns those names to those nodes. So that deals with the potential routing clients. And what Cisco have done, given, bearing that in mind, what Cisco have done is given you pretty much every extension range under the sun. So what happens when the script goes through that process and defines an agent via a skill group or whatever reason, it then does a check to say, is the agent extension within the extension range here in the targeting rule? And do I see it assigned to the routing client that kicked all this off? If the answer to those questions are both yes, then I go ahead and assign the dynamic label and deliver that back out to the routing client that provided that service. In CVP, CVP then is the client.
Yeah, it's just some message need to be inserted in the welcome message. Is that one you are talking about?
Let me go back here. No. Well, let me go back. When you're talking about the welcome, running a script that's playing the welcome message, that is managed, if you will, by one of these run external script nodes. And what this is sort of after we've connected to the VRU. So once we've done that, we're then able to deliver a command to CVP, which is, an instruction to play a particular micro app or maybe a VXML code or something of that nature. So we're really, in this discussion, we're sort of below that in the layer. We're still at sort of layer 3, if you will, where we're just dealing with signaling and labels. So, well, let me just go one further. So here's the way it's happening. We've got someone dials a dialed number. That's mapped to a call type. Our call type then points to a script. The script then initially has the send to VRU node. And what that essentially does is set up an IVR leg for this call. If we come back here, we'll look at our ingress gateway, our virtual voice browser, CVP, and ICM. So the introduction or the execution of that VRU node delivers an instruction back here to essentially set up an RTP session between our virtual voice browser and our ingress gateway. The caller is meanwhile sort of held on a port here. So that's happening in that VRU node. The next thing, if that all happens successfully, next thing we do is go to that run external script. And here in the run external script node, I'm delivering sort of commands one after the other to CVP, VVB, and that's when the command is playing out, the welcome message, et cetera, et cetera. So here where, in this discussion, we're sort of way before that application type environment, if you will. So we're still, now going to talk about how does CVP pass those dial plan instructions on. We're not going to be talking about in this section how CVP passes on those play external script messages. That's after we've done all this sort of stuff. And CVP is doing most of that using SIP. CVP is essentially a B2B back-to-back user agent, which is going to be able to provide, pretty much all of that functionality. It accepts all the inbound SIP invites, it passes them to CCE.
Yeah, okay.
Yep. Yeah, so we're saying that, CVP is accepting all of these inbound SIP invites, passing them to ICM as a route request. Route responses then, which is where we're at now, is sort of coming back in the form of labels to CVP and instructing CVP to move the call or to organize the call may be to a VRU or to an agent, depending on the label and depending on the instructions. The patterns or labels that are returned from ICM therefore need to be configured in CVP's dial plan. And therefore, if you will, from a CVP perspective, these patterns are considered as outbound patterns. So again, anything coming into CVP is automatically routed as a route request into ICM. Anything coming back from ICM requires configuration in CVP to deliver the call to the appropriate location. And we can sort of look at that in a high-level way with this slide. And while it's very high level, I think it's pretty instructive. ICM, the great decider, by virtue of the routing script, makes the decision. And it said, here's the deal. Any 1XX number is going to an agent. Any 8111 wildcard is going to the VRU. And anytime you get an error or ringtone code, 9191 or 9292, send that to the ingress gateway. CVP politely obeys all of those requests. So anytime ICM delivers, that send to VRU label, in other words, 8111, which was configured in the SPOG, CVP delivers that to the VVB and or VXML gateway, depending on the config. Anytime ICM determines there's an error, CVP will deliver 9191 or 9292 to the ingress gateway, and the caller will hear ringtone or an error. Anytime ICM returns 1 and a wildcard, CVP delivers that to call manager, and call manager then, with its own route pattern, recognizes 1XXX as a telephone extension and delivers that to that particular call. So ICM, the great decider, defining where these things belong, CVP acting in response to that to deliver the message, if you will, or control to the appropriate device. So where are all of these things configured, if you will? A couple of things need to be configured, and remember this is all SIP services, and because they're all SIP services, they need to be defined. And remember now patterns and paths, because just because we're using SIP services doesn't mean we're moving away from our patterns and paths. And we need to realize, I guess, before we can configure a pattern which is going to point to a path, that path is going to needs to be defined. So in the SPOG, then under route settings, as shown here, there are two objects that need to be configured for this CVP dial plan. One is a route pattern, the other a SIP server group. Now, don't get too hung up on the mechanics of this. This is just the way SIP works. And the way SIP works is that we first have to have a server group, and that server group then is going to define the devices in that group. And here we've got a call manager SIP server group that's been configured, and the devices, the patterns, are the publisher and our two subscribers. We've also got a virtual voice browser SIP server group, two elements or devices associated with that, which are our VVB1 and our VVB2. So they're really, if you like, our targets for this command or this sort of dial number configuration. Again, just so you're aware, these devices are coming from this or are available in this route setting screen because they have been previously configured and are showing up in our inventory for this service. But having defined those paths, we can now define the patterns that are going to send calls to these paths. Remember, it's all about patterns and paths. In this case, those patterns are referred to as routing patterns. And here we've got, and this should hopefully start to be, making a little bit of sense. We've got 4 routing patterns that have been configured, 1 and a wildcard, 8111, 9191, 9292, all with wildcards thereafter. Route pattern 1 is an agent route pattern type. Where does it go? It goes to the sunsetcc.com SIP server group. That SIP server group was what we created that is pointing to the publisher and our subscribers. All sort of matches, right? Our 8111 pointing to, which is a VRU pattern type, pointing to the VVB Sunset CC SIP server group. What is that SIP server group? It's the one we created for our virtual voice browser, which contains VVB1 and VVB2. So that's how ICM, will use these patterns, or become commanded, if you will, to use these patterns to deliver instructions back to CVP to do or to deliver the calls to these locations in CVP, in our CVP server configuration. Clearly, we need to do some corresponding configurations over here. Now, again, we don't, in earlier versions of CCE, we needed to go to our OAMP console to configure CVP. Here we doing it all via the SPOG, and we're doing it in the SPOG via the infrastructure settings card, the device configurations, and there are some global configurations that we can create. For instance, firstly, do we want to enable outbound proxy? Yes or no? Tick that if we wanted to. Clearly, we're not in this screenshot. What's the port number that we want to work on, and what's the protocol that we're running? Well, TCP on a well-known port 5060 is all defined here. So these are sort of global settings that are going to be recognized within the system. So what's really happening now is if we were deploying SIP proxy and we had checked that SIP proxy mark, again, ICM has no idea that CVP is using SIP proxy. So ICM works in exactly the same way. It delivers to CVP those same commands, but CVP now has outsourced that connectivity and is integrating now with SIP proxy, and SIP proxy is defining 811 in a particular direction, 9191, etc., and agent wildcards. So, the configuration in ICM doesn't care. ICM does not know or recognize SIP proxy as a device. It just does its thing and delivers that instruction to CVP. CVP can be configured to do one or the other of those services. Our VXML Gateway and Virtual Voice Browser also needs to be part of this dial plan, because this is the ultimate target. And again, you might wonder why, the ultimate sort of target needs to be part of the dial plan. After all, I'm not sort of delivering anything any further. There's no paths, but there might well be applications or something that I need to do with that number. So I certainly need to recognize the number and then recognize what sort of process that I should use for that. Now, the Virtual Voice Browser is a somewhat newer device. VXML applications were historically all done on an iOS gateway running some additional code. But with the VVB functionality, or the VVB server, that functionality has been taken away from the gateway and is now running on a virtual machine. You get to be able to use a VVB if you've purchased CVP ports, something that's been around quite a while. There are, you know, multiple sort of benefits and advantages said to be assigned to the virtual voice browser. And in the interest of time, I'm not going to sort of go through each of those in turn, rather to let you sort of ponder those yourselves. In terms of the administration, there's not a whole lot to do actually. Each server in VVB is a single host with SIP server group relevance. Those of you who may have come from a CCX environment would recognize the virtual voice browser as just a CCX server without CCX. So the engine is the same, the files are still .aef files, etc. There's a CLI interface that allows for shutdown, restarts, troubleshooting, etc. And there are 3 applications in our virtual voice browser that reference, if you like, or reference though the ringtone, the error tone, and the bootstrap, comprehensive. And this, of course, you know, the ringtone and the CVP are our 9191 and 9292. And we would hope that in the triggers for VVB, 8 in our case, 111 and a wildcard, is pointing to our comprehensive script, which is going to run our applications. So earlier in the VXML gateway only, a DNAS pointed to a dial pair, pointed to an application which ran a tickle script. In the new, that's in the gateway, in the virtual voice browser environment, the DNAS points to a trigger, points to an application, points to a .aef script, but the result is the same. And if it all works, you know, the caller hears whatever it is you're trying to get the caller to hear. So again, is that configured anywhere, you ask? Well, of course it is, and must be. So let me see if I can get to that. Because, would you believe it, we're back in the SPOG. When we run our deployment wizard, something that we've covered in these sessions, note that the virtual voice browsers are not configured or provided as part of that wizard. So we need to do this manually, and we'll do that back in the SPOG under the infrastructure settings, inventory card, where we'll add our machines. You won't be able to add the machine successfully unless you've done, you know, certificate work previously, which is a whole other topic. But nonetheless, we do need to add these VVBs in our SPOG. Under device configuration is now where we're going to define our patterns and applications for our virtual voice browser. Notice that as well as those patterns, there are some additional things that we can add here. For instance, connectivity to maybe speech recognition or text to speech, should we be using it. But that's again really outside our definition, if you like, of the dial plan. What we want to concentrate on is our dial plan. And under the applications and triggers banner of the virtual voice browser, we're defining, among other things, 8111 as pointing to the comprehensive application, 9191 pointing to the ringtone application, 9292 pointing to the error application. Now we're doing, I think this is important, we're doing this in the SPOG. So you're here essentially on an ICM admin workstation. You've browsed to the web administration tool, commonly known as the single pane of glass or SPOG. you're making these connections in here in this area, and you're actually writing this information to the virtual voice browser. So if you went to the virtual voice browser and looked at, the screens, you should hopefully see these triggers now as part of that communication. So, the SPOG, if you like, is an extraordinarily useful box, I guess you could say. In the gateway, now, even though virtual voice browser is the brave new world, back in the iOS gateway, if we are including VXML coding in that gateway, then we need to set up some particular dial peers here, and it's the same goal as we just referenced on the VXML on the VVB, the same goal here on the VXML gateway, but it's just a different platform. So when the incoming call arrives here with the DNS of 8111 and the wildcard, whatever that wildcard is, T is a wildcard, for instance, the dial peer kicks off an application named Bootstrap, and Bootstrap Tickle, to give it its full name, is loaded as an application, and Bootstrap Tickle then calls up Bootstrap VXML, and it runs then that VXML application in just the same way the comprehensive script in the virtual voice browser would have done the same thing. So we have the option of either virtual voice browser or VXML gateway, but the clear direction is towards the VXML gateway. And I know we've reached our hour, but a couple more slides just to go through, because we want to also talk about the dial plan with reference to Call Manager. Call Manager clearly is part of this environment. We're assuming here that Call Manager is in and functional for back office use already. There are some things then we need to check. We need to check our enterprise parameters for CVP and CUSP config. We need to make sure that we've got some SIP trunks configured correctly. We need to ensure that we're pointing to either a SIP trunk or a JTAPI connection, depending on where we're wanting to deliver the call. And both of those results, both of those protocol choices and the SIP trunks end up sending a route request into CCE. One way, is the sort of long way round, which will have a CVP routing client. The other way, an expressway, which might be a Call Manager routing client. And there are some reporting implications for the decisions that you might make in that regard. So here, again, is another sort of high-level decision, I guess, that you make as a configurer. Let's say you have an agent here who wants to deliver an 800-555-3952 call into ICM. There are two ways to get there. I could have Call Manager deliver up a SIP trunk via CVP to Call Manager to ICM, or I could go straight via the JTAPI protocol into ICM. So what's the shortest path? What's the reporting implications? There's no wrong or right answer to the decision that you make. It just depends on the way in which you're going to be deploying and, I guess, reporting on this system. Again, realize, though, that in our Call Manager environment, we're going to need to make this work in any way at all. The specific route patterns, the dial plan patterns are going to be used to point to SIP service, and they'll reference a SIP trunk or a route point that is going to point to the JTAPI link as a transport protocol. So either of those sessions or either of those options are configured in Call Manager. Call Manager in the enterprise parameters must have the cluster fully qualified domain name, which matches exactly the SIP server group name you configured in the SPOG. So again, you know, there's the tie-in. So when I define the SIP server group, I'm clearly going to that call manager cluster because call manager recognizes that as part of its environment. If I'm using SIP trunks with no proxy, or if I'm connecting to CVP with no proxy, then when I see a particular dial pattern come in, which we haven't put in yet, but our paths, I've got two paths here, both are SIP trunks, and they both point to my CVP servers. .25 and .26 are my CVP servers. So what that's doing is saying, here's CVP, here is call manager. CVP would already have a connection to call manager, but call manager needs to be configured with a return path. And that's what this is doing. It's providing SIP trunks to both of my call servers. Clearly, there's no SIP proxy involved here for call manager. I'm just connecting directly. And that is an option that you can choose to use. If I were using SIP proxy in this version, then I would need to point not to my CVP server directly, but to my SIP proxy. And the SIP proxy IP address is here. And the protocol, oops, if you're using SIP proxy, then it's the same process. We're setting up a SIP trunk, but rather than set it up to CVP, which is a fairly simple configuration, I'm now setting it up to SIP proxy. And because I'm now setting it up to SIP proxy, there are some additional trigger and network entries which need to reflect what's been configured in CUSP. Clearly, I also need to define the appropriate IP address, which is the IP address of my SIP proxy server. They are the paths. My patterns, remember this whole thing is patterns and paths, configured also in Call Manager as route patterns. And each of these route patterns, such as they are going to point to the particular trunk that I want to be as the path of that device. And it might be trunks to CVP, it might be trunks to SIP proxy, depending on the way in which we want it to go. Now, in this case, you know, we're pointing these paths back up to CVP. And we have a route pattern that's going to do that. In that sense, we're taking, you know, essentially the long way around. Here is another approach that is not using a route pattern, but a CTI route point, which is our pattern that's pointing to the JTAPI path. And that means, if you sort of step back one, that call manager, PG, ICM, here is my JTAPI protocol link. What I'm creating is a route point that allows an agent to dial a particular number, have that delivered via the JTAPI link directly to ICM rather than, you know, go via CVP. Is there a right way and a wrong way? Well, no. Do people decide to do it either way? Well, yes. Reporting, you know, is sometimes an issue, depending on, you know, what reports you can get from CVP versus what reports you can get from Call Manager and ICM. And at the end of the day, you know, the decision is going to be made, you know, based on those sorts of environments. Remember that where does this sort of 6111 come from in terms of, you know, route points, etc.? Well, remember that if we're going this way, as described on the screen right now, Call Manager is the routing client. So the sender VRU node that we encountered when we went into ICM this way is going to deliver the label 6111. And therefore that 6111, let me maybe go back one. 6111, as we're saying here, is pointing up to CVP. So at the end of the day, we've got to get to CVP in some way because CVP is interfacing with our virtual voice browser and things of that nature. Lastly, significant digits. Significant digits is a process by which we can keep calls coming in on a particular side A, using side A resources, side B calls using side B resources. It's significant in the context where the service provider might be providing some load balancing of their toll-free numbers across side A and side B gateways. So what we're going to do when the dial number comes in, we're going to prefix side A with a particular, in this case, 2-digit prefix, and side B with another 2. So we need to tell CVP that we've added a couple of these digits, because it needs to strip that off when we're delivering that dial number into ICM as a dial number, otherwise it won't recognize it. And when it comes back from ICM with the label response, then we need to reappend that 44 or that 45, depending on where we're wanting to go. This sort of process is also known as strip digits, prepend digits, prefix digits, etc. Significant digits really encompasses all of that sort of thing. So the goal then is to keep the same DN to the ingress gateways on side A or side B. So if the PSDN is load balancing across these gateways, and I return a response, to this CVP or that CVP, we want, if the call has come in from here, we want to return it to that gateway. If the call has come in from here, we want to return it to that gateway, because, and it seems like that would be obvious from here, but what's sort of not shown is we, of course, have got, connections to our other gateways as well. And it may be that, we want from time to time to deliver it to another gateway. But most of the time, using our significant digits, we're going to deliver these calls accordingly. We'll append the digits on the ingress gateway using these commands. Notice here that this is a side A snapshot of a snapshot of a side A gateway, and this rule 1 configuration is responsible for appending 44. If we were to look at a side B gateway, we'd have the same sort of iOS dial pairs, etc., and rules, but we would be appending 55. So that's how we're appending one or the other. Back here, again, in the SPOG, under the CVP server configuration, we're telling CVP, hey, we're telling CVP there are 2 digits which are really not part of the dial plan, 2 significant digits, so take those out. And so we're going to, but when you take them out, remember that you've done that, because when you're delivering the label back, we want you to reappend those services or those numbers. In the SPOG, we need to create new CVP patterns and paths, because if it's going to take numbers, back off, then the SPOG needs to know how to route these new patterns, which are similar, but they're now unique. So we've now got those same 8 111 wildcard numbers, but with the 55 and 45 appended, one going to side A and one going to side B. Inform the virtual voice browser and the VXML gateway about the significance of those digits as well. So again, 55 and 44 as prepended digits needs to be included as triggers in our virtual voice browser. Now, having said all that about significant digits, do I need to do that? Well, no, you don't. You could use alternative or unique labels, because remember, when a routing CVP, which is a unique routing client, side A or side B comes in, we could create a different label for 1A or 1B, and job done. okay? In other words, uncheck this same label for all unified CVPs. And we've got it. Now, what's the best way to do it? I personally, and it's probably because I'm not sort of that familiar with gateways, I personally would use unique labels. The only problem I would think you might come into with unique labels is in the, your numbering plan and the extent to which your numbering plan sort of runs out of duplicate references or duplications or things like that. The other thing that we're talking about here is the maximum length of the DNS. Remember, we talked about the fact that the 10-digit label was significant in the sense that it needed to be defined as a 10-digit label, and that's again done here in the miscellaneous section of the call settings tab. Why that's important, of course, is that remember we add a correlation ID, and that correlation ID, can be a goes from 1 to 2000. So our whole label, which is made up of the label plus the correlation ID, is a variable length. So how does the system cope with that? How does it know when the label stops and the ID begins? Well, it knows because we've told it count to 10. Okay. So that brings me to the end of this session on numbering plan for PCCE. Questions, we can deal with those now, or you can be mulling over those while you're writing down TT20 for 20% off these CCE courses, which are new courses in and around 12.5. So please take note of that and take advantage of that 20% discount. You don't see here CCEEI, which is the implementation course from which this material has been taken. And that's because it's not been launched yet by Cisco. But when it is, you may well see that as part of that promo code as well.